Okay, we're going to get started on our notes for today, and that is differential equations. Sorry about that. Day one. Differential equations is a commonly asked topic in AP. It's also a topic that is not that bad, I promise you, except if you can't do the first step, which the first step is one of the simpler steps, but for some reason, a lot of people forget to do it, and then it all just goes crashing and burning. So let's describe what a differential equation is. It's an equation that contains an unknown function over one more of its derivatives. So pretty much it just gives you dy over dx equals two separate types of x and y functions, and you just need to separate your variables and find what your y is, find what your x is, and then go from there. Okay, so it's pretty much going to give you the derivative in terms of x's and y's, and you need to find the original equation. Sometimes they'll give you initial problems. That's what this well, maybe it's not up here. It'll give you initial conditions so you can actually find everything out. So here's the steps to do it. Is to rewrite by moving all the y's to one side and x's to the other. So this says pretty much separate your variables, and that's going to usually be a point on AP. And then you just integrate both sides and then solve for y and plug in a c value if you can. And that's really all the steps. So before we actually get to doing a differential equation problem, is y equals e to the negative t a solution to the differential equation? Right here. So sometimes AP will just straight up ask you, is this true? And you don't need to do too much calculus here. You just need to do enough. So you need to figure out what y double prime is, what y prime is, and just plug it in and see if it works. So this is y. Y prime is going to be negative e to the negative t, because it's going to be a chain rule right there. And y double prime is going to be e to the negative t, because you would get negative e to the negative t. All you do is just plug this in. We're just verifying. We're not trying to solve for this, which is the reason why I do this problem before I actually do any of the differential equations, because some people think like, oh, I need to solve for this. Well, you can't solve for it with the tools that you currently know. So here we go. I have e to the negative t, so I have 2e to the negative t's. And then I have minus 2e to the negative t, which is, this is true. So is that the solution? Answer is yes. So that's one type of differential equation problem. That would be a multiple choice usually. It wouldn't be a yes or no, but it would probably give you like this function, and it would give you like a bunch of these equations saying which one of these is true. So here we go. So this will be our first example of actually doing a differential equations problem. So given the differential equation, solve for y as a function of x. So we need to solve for y here. So I'm going to get y's and x's on separate sides. So if I cross multiply, I'm going to get y dy equals 2x dx. I just leave my dx's and dy's in the back. The reason is so that I can go ahead and integrate. That is the whole point of doing this. You have to separate your variables. That's one point. And then the integration is usually the step itself. So the antiderivative of y is going to be 1/2 y squared. I don't put a plus c because I could put a plus c on both sides, but what's going to end up happening is if I get a c over here and a different c over here, I got to move the one c, which is different from the other c, over, and then it becomes a whole nother c. No reason to do that. Just put 1 plus c at the very end. And this is going to become x squared plus c. So just put a plus c at the very end, because again, this would produce different constants, and then you have to move them over. It's too much. So what I usually do is I usually plug in, if I can right away, as long as it's not a log function. If it's a log function somehow, I actually solve for y first or do a little more cleaning up. But you can actually plug in right away. You don't need to solve for y quite yet. And I think it's easier to plug in right away, because if you were to solve for y first, you're going to get the square root stuff. It just gets a little messy. So let's not do that. So let's plug in my initial condition. So this is saying that y is -3 when x is 1. So and the whole point of this is I want to find what my c value is. Okay, so I'm going to get this right here, which is going to give me 9/2 equals 1 plus c. Subtract that 1 over. I'm going to get 7/2 equals c. So this equation right here is going to give me, let me use a different color, 1/2 y squared equals x squared plus 7 halves. Now I'm ready just to solve for y. So to do that, multiply everything by 2. I'm going to get y squared equals 2x squared plus 7. Okay. Now we're going to square root both sides. When I square root both sides, I typically have a plus and minus. I'm going to put that in a different color because it's actually not going to be our answer, and I'm going to explain why. I want to put it in a different color so that we can talk about it and see what actually happens here. It's going to be plus or minus 2x squared plus 7. Okay? So this is either going to be the plus or the minus. We have to figure out which one it is. Now, if I'm capable of spitting out a negative value for y, is it going to be positive or negative? Again, for my initial condition here, I'm spitting out a negative value. Well, since I'm able to spit out a negative value, I'm going to go ahead and use the negative. So my function is going to be negative root 2x squared plus 7. So there you go. That is a differential equations problem. Okay. If I would have solved for y first, I would have had this plus and minus here, and then I would have had to plug all that stuff in. It would have just got a little messy to solve for c. So it's easier to clean up your mess a little bit, solve for c before you actually go ahead and solve for y. Okay. All right, last example here. Just a little bit different notation, but really the same problem, more or less. So solve for y as a function of x. So this y prime is the exact same thing as saying dy over dx. So don't get tipped off by that. So I need to separate my variables. So I'm going to divide that root x over. So I'm going to get dy over root y equals x squared dx. And now I'm going to go ahead and take the integral of both sides because I have to solve for y. Now the integral on the left looks kind of wonky. If we were to rewrite this as y to the negative 1/2, it's a little bit better. So what's the antiderivative of y to the negative 1/2? Well, it's going to be 2y to the 1/2 equals 1/3 x cubed plus c. And now let's go ahead and plug in my initial condition here to solve for that c value. So when I plug in, get that in purple, I'm going to get 2 4 to the 1/2 equals 1/3 times 3 cubed plus c. I think this cleans up pretty nicely because 4 to the 1/2 is just 2. 2 times 2 is 4 equals, this is 9 plus c. You're going to end up with c equaling negative 5. So in green, I'm going to end up with 2y to the 1/2 equals 1/3 x cubed minus 5. All we're going to do now is just solve for y. So divide everything by 2 would be the way to go here. So we're going to get y to the 1/2 equals 1/6 x cubed minus 5 halves. And then we're going to go ahead and I'm just trying to look at like my math I want to do here. I'm going to go ahead and square both sides now. So I'm going to get y equals x to the 6 over 36 minus, oh boy, I just did some bad math. Ooh, the math gods would not be happy with me. Holy cow. That never happened. That never happened. That never happened. Okay, all right. Let's do this the real way. When I square both sides, I'm going to get y equals 1/6 x cubed minus 5 halves all squared. So you got to square everything on that side. I was going to say this is too easy. Well, you have to expand it now, and then distribute. So this is now going to give me my 1 over 36 x to the 6th. I'm going to use my little cheat sheet here because, oh, well, of course, my cheat sheet has different stuff because they did smarter things what I did. Minus 5/6 x cubed plus 25 over 4. I believe that's 5/6. I'm doing it in my head. So because you're going to get negative 5/12 minus 5/12, which gives you negative 10/12, which is negative 5/6. And there you go. That's your answer. Could clean it up a little bit more if you want to just take out a GCF here. But that is, yeah, that's going to be it for that problem.